Hey guys, it's David with Cars and Code. This video is a continuation of previous videos, so if you haven't seen those yet, please click the link below and watch those before you watch this. So in this video, we're going to be going through some math and actually figuring out how to get the acceleration of the car that the phone is sitting in instead of just the actual phone. So what we have to do is take the acceleration experienced on the phone and convert it to a coordinate system for the car. And a lot of this is going to be set up when the user initially presses that calibrate button. That calibrate button is going to figure out the coordinate system for the car based on the direction that gravity is pulling. So in order to explain this a little better, I'm going to pull up a vector plotter to show what I mean. So here we're going to have a phone in our hands that looks a little bit like this. So the front of the phone is going to be tipping up, but everything else is going to be mostly flat. And that means the gravity is going to be pulling down towards the bottom of the phone and a little bit down towards the back of the phone as well. So if we're looking at this chart right here, this axis represents the phone. So this is the x-axis on the phone, this is the y-axis on the phone, and this is the z-axis on the phone. The blue line shows the gravity that is pulling on the phone. The red line is going to signify the front of the car. Now we have to assume a direction for the front of the car. So we're going to assume that the positive y-axis, the positive y direction, is going to be at the front of the car. So when the user presses the calibrate button, they're going to have to make sure that their phone is pointing in the right direction. So what we have to do from this information is figure out the direction for forwards on the car and the direction right on the car. And then when we have those two vectors, then we'll be able to project a current acceleration of the phone onto that coordinate system to show the current acceleration of the car. So the first part is actually relatively easy. In order to get the direction that's right for the car, that is the x-axis of the car, all we're going to have to do is take these two vectors and take the cross product of them. Now this is because these two lines are making a plane, right? These two vectors describe a plane. And that plane is going to be the y and z axis on the car. Now, if we take a line or a vector that is orthogonal to that plane from the origin, that is going to be the x-axis. That's the definition of what the x-axis is. So if we take two vectors that are on that plane coming from the same location and take the cross product of them, that's going to give us the x-axis for the car. So if we tap this button to show the cross product for V1 and V2 and draw, we can see that the green line is now going to be the x-axis for the car. So we have that vector now, which is awesome. The next thing we need to do is find the forward direction for the car. And now that we have the x-axis, we can take gravity, which again is straight down. So this is the line that is straight down. That's the z-axis, the negative z-axis for the car. And the right x-axis, and if we take the cross product of those two, then that's going to give us the front of the car, in the positive y direction for the car. So I already did that before making this video, so I'm going to type that in here as vector number 3. So if we draw that, we can see now that the yellow line is pointing forwards in the axis of the car. So if you look, you can kind of see the axis of the car now. We have the negative z-axis, we have the x-axis, and we have the y-axis, and that kind of makes a cube. So we can see right there that cube, that is the coordinate system for the car. So now all we have to do is when we get some acceleration vector on the phone, we just have to project it onto the car's XY axis. And the way we're going to do that is we're going to take the acceleration vector and do some trigonometry to project it first onto the x-axis of the car and then the y-axis of the car. So I've got another screen here set up for that. So let's say, for example, this is our current acceleration, this yellow line. The blue line in this case is going to be the forward direction of the car, and the red line is going to be the x-axis, the right direction for the car. So all we have to do is take this current acceleration that the phone is experiencing and project it onto this red x-axis line, and then that's going to give us the magnitude for our x direction. Once we've done that, we're going to project it onto the blue forwards y-axis for the car, and that's going to give us our front and back acceleration for the car. So now in order to do that, I'm going to throw a little bit of math equations on the screen. So first, in order to project the yellow line, the current acceleration, onto the x-axis of the car, the right direction on the car, we have to first figure out this angle A. And once we have this angle A, we can just simply use cosine of this angle A is the y over x, the close side, the adjacent side over the hypotenuse. So how do we find this angle A? Well, there's this formula, cosine of theta equals the dot product of x and y over the norms of x and y multiplied together. Now, norms are just the magnitude. So in order to find the magnitude of a vector, it's just going to be the square root of each of its x, y, and z components squared and added together. So using this formula, we can just plug in the numbers for x and y, and that's going to give us this angle A. Now that we have that angle A, we just use this formula, cosine of A equals adjacent over hypotenuse, and that's going to give us this y, the magnitude for y. So once we've done that, we have our x acceleration for the car. The next thing we have to do is do this exact same thing for the y acceleration, the front and back acceleration for the car. And once we've done that, we have our two numbers that we want to show to the user on their friction circle. So let's go and actually write some code. So the first thing we're going to need to do is grab a NuGet package to do some vector math for us. And this NuGet package is going to be called aforge.math. Okay, now that we have aforge.math installed, we can actually go and start using it. So we're going to come down to our calibrate command, and we're going to pretty much grab the forward, the y-axis for the car, and the car's right axis. So we're going to use those same cross products that I talked about earlier. So first, let's create a new vector 3. That's the aforge.math three-dimensional vector object. Now we're going to create a gravity vector. So this is just going to be the x gravity, y gravity, and z gravity. Now that we have that, we're just going to hard code the phone's forward vector, which is just going to be 0, -1, and 0. We're going to be using -1 because we need to flip the numbers eventually. Once we have that, we can calculate the car's vector to the right, the x-axis right value for the car. And that, again, is just the cross product of the gravity vector and the phone's forward vector. Now we're going to take that value and we're going to store it in a private variable so we can use it in our onAcceleration_changed. While we're creating that private variable, let's also just create the car forward vector variable so we can use that as well later. Now that we have those created, let's go ahead and assign the car right vector to the cross product of the gravity vector and the phone forward vector. Now that we're done that, we can calculate the car's forward vector, which this time again is just going to be the cross product of the car right vector and the gravity vector. If you don't understand this, go ahead back to the beginning of the video and watch that again. Okay, now we have the forward vector and the right vector for our car. So now if we go back over to on acceleration changed, we can actually do that trigonometry to calculate the angles for the current acceleration between the current acceleration and the right x-axis for the car and the y-axis for the car. So first, let's just grab the current acceleration vector. Okay, now we have the actual acceleration vectors along with the car right vector and the car forward vector. So first, let's grab the angle between the actual acceleration and the car right vector. Now in order to do that, I'm going to write a private function to do this for us, and I'm just going to call it angle between vectors, and it's going to pass in two three-dimensional vectors. Now if you remember this formula, it's just going to be cosine of theta is a dot product of x and y over x norm and y norm. So we're just going to do the arc cosine of x of this whole right side of the equation. Okay, now that we have this function, we can actually go calculate the angle between the actual acceleration and the right axis of the car. So this should give us our magnitude to the right, which is going to be the actual x acceleration for the car. Now we're going to do this exact same thing, except we're going to do it for the forwards direction for the car. And once we have these values, we can assign them to variables. Now we already set y as a negative, so y has already been reversed, but we still have to reverse the x direction to make it look right with the friction circle, because that's just how the friction circle works. If the phone experiences an acceleration to the right, we want to show the dot moving to the left. And once we've done that, we can actually go run the application and see how it works. So here we have our friction circle app running, and notice there's no marker on it yet, and that's because we haven't hit the calibrate button yet. So if we do tap the calibrate button, we get that dot to appear, and it's in the center because it's calibrated. Now we can move the phone and simulate an acceleration forwards and backwards. So if we move the phone forwards, it jumps to the back, and if we move it backwards, it jumps forward, just like you would expect on a regular friction circle. We can also start moving side to side, and we can see as we accelerate from side to side, it's moving side to side. Now the cool thing is we can actually set this up sideways and it'll still keep doing the same thing. So if you hold this phone completely sideways and hit calibrate, it'll go back to the center as you would expect. But remember, the front of the phone is still going to be associated with the front of the car. So now we can move it forwards and backwards, and we can move or see how the dot is moving forwards and backwards. Now we can also start moving side to side, and we can still see how the dot moves side to side even though the phone is completely sideways. And as you would expect, if you move the phone up and down, the dot doesn't move around too much, other than the jitteriness because I'm holding it with my hands. So that's exactly what we want, because we're just measuring the x and y acceleration of the car. So that's going to be the end of this video. I hope you guys enjoyed it, and I will see you next video.